In a photovoltaic solar system, the inverters convert the DC electricity produced by the solar panels into AC electricity. Till today, the vast majority of solar systems use string inverters. In these systems, the solar panels are wired in series to form a string. Solar panels wired in series add more voltage to a string. One or more strings are wired to an inverter in parallel connection to add more current or amps. String inverters have a limited power range, and large solar systems need several inverters. This system is used all over the world and has proven to be the most cost-effective system, but there are a few drawbacks. The first major drawback occurs when a part of the solar panels are shaded. When one or more panels produce less energy, the power output from the whole string is reduced to the level of its weakest panel. This can drastically reduce the power output of the whole system. Areas that are known to get shade cannot be used to install solar panels. This reduces the amount of utilized roof space. Secondly, for each string inverter to work properly, every string must have an equal number of solar panels. They all have to be installed in the same angle, and all panels have to be of the same type. This doesn't affect a larger solar system much, but for smaller solar systems, it can be quite a challenge to meet these three criteria and design the most productive configuration that fits on the roof. If you want to install panels on different sides of the roof facing different directions, you would need an extra inverter for every different angle, which is most likely not cost efficient in a small system. This is another major drawback. There is also a safety issue with traditional string inverter systems. In case of emergency, the utility grid can be shut down, but not the solar panels. The panels will keep producing electricity as long as the sun is shining. During a power cut, the inverter will stop the electricity from flowing into the power lines, but the cables from the roof to the inverter will still be under high tension. To solve the problems of a string inverter system, the solar industry had to come up with a solution. Today, there are two options available in the market: micro inverters and DC power optimizers. Micro inverters came first. In a system with micro inverters, the function of one big inverter is split into many little inverters. The micro inverters are installed under every solar panel and convert the electricity from DC to AC right there under the panel. Every micro inverter can be connected directly to the grid independent from other micro inverters in the system. When one panel gets shaded, it will not affect the performance of other panels. The right voltage is found through a technique called maximum power point tracking, or MPPT. When maximum power point is applied at panel level instead of a system as a whole, performance will naturally increase. The configuration of a system with microinverters is very flexible. Solar panels can be installed in various angles, and different types of solar panels and microinverters can be added to the system. For safety reasons, when the power fails, microinverters shut down and stop feeding electricity into the cables. Microinverters are rapidly gaining popularity, particularly for residential solar systems, but they are far more expensive than systems with regular string inverters. When DC power optimizers were introduced, they became a more affordable option. This system splits the traditional inverter in two products: a power optimizer and a simplified inverter. The power optimizers are located under each panel, turning them into intelligent modules. By using panel-level tracking and real-time adjustments of current and voltage, the power optimizers maximize system output to the optimal working point of each panel. When one or more panels are shaded or face different directions, the performance of each string is optimized such that the underperforming panels do not affect the output of the other panels in the string. Compared to the limited design of traditional string inverter systems, systems with power optimizers are very flexible. it enables connection of much longer strings and different types of solar panels can be added. For safety reasons, during a power cut, the power optimizers reduce the power output of each panel to a low and safe voltage. Microinverters and power optimizers are also referred to as module-level power electronics or MLPEs. A great benefit of systems with MLPEs is that the performance of each panel can be monitored individually. The performance of each panel is sent to a database, and authorized people can log in to a website to view the status of the system. This is a great benefit for maintenance workers. They can remotely analyze the problem and come to the site prepared to perform the maintenance. Overall, systems with MLPEs are more efficient and will produce more power than a similar system with a traditional string inverter. They are still more expensive than a traditional system, but prices are falling as their popularity grows. MLPEs have better durability, a longer lifespan, and they come with a longer warranty period. Our team will be happy to assist you in finding the most suitable solution for your needs.